Alright, hi again everyone. So, got things rewound and been bouncing back and forth with different windings and designs, but this would be kind of what I've landed on right now. So, basically the Tesla coil, I was trying to get the 2 megahertz kind of target, and in the past I had been using these kind of smaller coils, and this one I couldn't get below 1.6 megahertz, and I figured it was parasitic capacitance, so I wound one of the most difficult things I ever wound, just to see if I could get any parasitic capacitance out of it, and this one went as low as 1.5 megahertz, but something about the diameter was preventing it from going any higher. So finally this one was able to hit 2 megahertz on the nose, and worked pretty well, except the voltage just wasn't very high. Just with not very many turns, the frequency would get lower. So this is really skinny diameter. It's next to your thumb. It's not very wide at all. A little over 1 inch, less than 2 inches probably. So anyway, the voltage was just so low that I decided to go back with this guy, and yeah, you can get some really easy burns off of this one. Right now with the lights, of course it killed the lights there. Just restart it. There we go. So yeah, this I just used as an indicator, but burned itself off earlier. The glue started to melt and just started to go on fire up there. So I've got it really lined up nice with the phasing. Right now the Tesla is going at 300 kilohertz, 303, and the push-pull at 101 kilohertz, and that's the same signal frequency on the lights. So right now the green trace is measuring the push-pull driver, which I switched out and rebuilt to a ZVS driver. That in the past had just been the most bulletproof, and tried to rebuild that actually, the one that was posted by Geofusion and a number of people, but I had some kind of short circuit somewhere and could not figure out where it was, so yeah, put this guy together and can adjust the frequency with these capacitors just across the primary of the center tap winding there. And yeah, with 50 nanos, it rings about 100 kilohertz, and that combined with optimizing the capacitance on the bifilar coil, that's indicated by these 2 lines, that's the bifilar coil, and so that and having a ferrite rod down the center of it is what keeps it in this locked phase here. So I'll unpause it, and you can see it's gonna be shifting around because things aren't completely stable, but no matter where I pause it at, you can see that we're in the negative cycle of the 4th wave. It's just totally locked in that frequency phase alignment. Pretty nice. So anyway, that 3 times the frequency is what brings the light up, and we can switch off the Tesla coil, switch it on, off, on. The camera's kind of tricking. It really is a dramatic increase that the Tesla gives. Which up until this point, from the last video, it's taken this long to get the Tesla coil to produce a boost. And I think that's just from having higher voltage on this one and the frequency alignment, optimizing the capacitance on the bifilar coil. And yeah, if we disturb it at all, it probably go out. Yeah. So not disturbing the Tesla coil once it's in operation is pretty important. But right now it's just barely glowing. So usually I'll just have to reset it here. And that'll bring it back up. But yeah, finally the Tesla coil is having an effect on the system again. And I've rewound this coil, the grenade winding and everything, but for some reason that 2 megahertz just didn't seem to do as much as this Tesla coil is doing at around 300 kilohertz. So, but yeah, I'm pretty happy with this ZVS circuit, being able to stack a lot of capacitance on, and I can switch this guy and then do it on the fly. So can just switch from below 10 kilohertz up to 600 kilohertz on the fly. And yeah, things are going pretty nice. Even have a amperage measurement on the output here. But for some reason with this wiring arrangement, the voltage is so high on the output that I need to have 3 lights. I can't use a single light, and that might be what's messing up a lot of people, is not using enough light. So either there's arcing going across and just blowing past the light, or the current is so low that it's not doing anything, and you just can't tell because you're not getting any light. So but with the 3 lights identical to each other, something is important about that. And I've had even 6 of these things running, and can get it up to 2 amps on the output, but it throws off the tuning. So there's something important about having this amount of resistance on the output. But things are going nice. And I will talk to you guys soon.